Now let's start another topic uh, in which we will solve the previous year questions. So first, we have already solved from time evolution of wave function, and then we also worked on few questions, like not few, at least 10 questions from commutators. Now in this video, we will try to solve the previous year question from operators. So here, first question is first we will choose it from December 2015. This question was asked, and the question is: suppose the Hamiltonian of a conservative system in classical mechanics is h omega s xp in the term of position and momentum, where omega is constant and x and p are the position and momentum respectively. The corresponding Hamiltonian in quantum mechanics in the coordinate representation is. So what we have to find is we have to write this Hamiltonian in quantum mechanics because it is written in the classical mechanics. So let's first write all the Hamiltonian position and momentum in operator form. So let's write solution. So we can write Hamiltonian, classical Hamiltonian, quantum Hamiltonian as h cap. Position can be written similarly, and momentum can be written as p cap is equal to minus I h hat del upon del x. So the question is, can we directly put this position and momentum in this classical form and get the quantum mechanical Hamiltonian? So let's check it. So just first we write it x omega x and p cap. This is quantum mechanical Hamiltonian. Okay. So what is the property of quantum mechanical physical observables? The value should the observable should be real. So the operator should be Hermitian. So we have to check whether this operator, this form of Hamiltonian, is Hermitian or not. So how can we do that? Let's check it. H cap dagger is equal to omega x p cap dagger. So omega is constant, so we can write it outside, and x p cap dagger, we can write it as omega p cap dagger x dagger, and we know from commutation relation x p cap is not equal to p cap x because xp commutation of xp is not equal to 0. Okay, so and we can here write omega is equal to p cap x. So this is not equal to h cap. So this is not Hermitian. Then we cannot directly write quantum Hamiltonian just by putting quantum mechanical Hamiltonian just by putting the operators in the classical Hamiltonian. So what we have to do, we have to write it in a form such that it cumulates its Hermitian conjugate. So we have to find it. We have to symmetrize the x and p cap. So how can we do that? Like x p cap, we have to write. We can write it in 1/2 x p cap plus p cap x. we have to write it in this form. Now let's write the Hamiltonian. So we put it in the classical Hamiltonian term, omega by 2 x p cap plus p cap x. Now let's check whether this is Hermitian or not. So we can write h cap dagger is equal to omega by 2. This is constant term, so we will take it outside. X p cap plus p cap x dagger is equal to omega by 2 x p cap dagger plus p cap x dagger is equal to omega by 2 p cap dagger x dagger plus x dagger p cap dagger. So we can write omega by 2 p cap x plus x p cap is equal to h cap. So from here we can see h cap dagger is equal to h cap dagger is equal to h cap. So it shows that now what the Hamiltonian which we have constructed here is Hermitian. So this will give real value. Now what we will do, we will put the value of momentum in this and then operate it on wave function psi to get the final result. So h cap is equal to omega by 2 minus I h cut del upon del x plus x minus I h cut del upon del x. So we will choose an arbitrary wave function and operate Hamiltonian on that wave function at psi omega by 2. Take minus I h cut outside. This will give del upon del x plus x del upon del x psi. So minus I h cut omega by 2 del upon del x psi plus x del upon del x psi. Now solve it. What we will get? X del psi upon del x plus del x upon del x will be 1. So just we will get psi plus x del psi upon del x is equal to minus I h cut omega by 2 psi plus twice x del psi upon del x. So minus I h cut omega 1 upon 2. Take 2 inside, 1 upon 2 inside, plus and psi, take psi common, x del upon del x psi. This is h cap psi. So h cap is equal to minus I h cut omega 1 upon 2 plus x del upon del x. This should be the solution. So let's check the option. First minus 1 by 2. So minus I h cut omega x del upon del x plus 1 upon 2. This is the solution. Now the next question is, this question was asked in June 2015, and the question is, the waveform of a particle in one dimension is denoted by psi x in the coordinate representation and by phi p in the momentum representation. This is in the real space representation, you can say, in the coordinate representation, and this is in the momentum representation represented by p of the particle in a one dimension. So if the action of an operator t cap on psi x, if v t cap is operated on wave function psi, is given by t psi x is equal to psi x plus a. So where a is a constant, a is a constant value, then t phi p is given by, so we will what will happen if we operate t cap operator t on phi p, wave function phi p, or in the wave function in the momentum space. So let's see. So what we have given is psi x real space wave function and phi p momentum wave function. Now another thing what we have given is, when we operate t cap on psi p, psi x, this will give psi x plus a. It is a translational operator, we can say. So now what happen if we operate t cap on phi p? So we can write it as t cap integration, what is psi x e to the power minus I p x upon h cat dx. Now we can write it as integration psi x plus a e to the power minus I p x upon h cat dx. So this will give us, so what we can write here is, we can multiply e to the power minus I p a and it was minus it was I p a. I p a on h cat integration psi x plus a minus I p x dx. So this can further be written as e to the power I p a upon h cat. This whole part is a constant, so we can take it inside the integration. Psi x plus a e to the power minus I p x plus a, we can write it like this, and dx. So the next part is what we can write it. This is the translation of phi p plus a. So we can directly write it as phi p. So this can be written as e to the I p a upon h cat phi p. So let's look at the solution. It was IAP upon h cat phi p. So C. Solution is C. Okay. Now next question is this question was asked in December 2015. So the question is a Hermitian operator O cap has two normalized eigenstate 1 and 2 with eigenvalue 1 and 2. So what does it mean? It means if we operate O cap on 1, it will give 1 1, eigenvalue is 1, and if we operate O cap on 2, it will give 2 2. Okay. The two states U is equal to cos cat 1 plus sine theta cat 2. So this is U is the linear combination of 1 and 2, and V is also the linear combination of 1 and 2. And by looking at the wave function, we can clearly say that it is normalized, because when we take scalar product u, this will give cos square theta plus sin square theta, and this will give sin square phi plus cos square phi. Now, and uv is orthogonal, u and v is equal to given. So what we will do are such that u and v is equal to 7 by 4 vv. So expectation value of O is 7 by 4. So which of the following are possible values of theta and phi? So we have to find the value of theta and phi. So how do we solve it? So write the solution. Here V O cap V is equal to, we can write 1 cos square phi, cos phi, sorry. This is cos phi plus 2 sin phi O cap cos phi 1 plus sin phi 2. So solving it or simplifying it, cross term will give 0. So as 1 and 2 is orthogonal, so this cross term will be 0, and this cross term 2 and 1 will be 0. So we will write only similar term. 1 cos phi is cos square phi O cap 1 plus 2 sin square phi O cap 2. So O cap operating on 1 will give 1 cos square phi into 1 plus 2 sin square phi operating on 2 will give 2. So taking cos square and outside, cos square phi 1 will give 1 plus 2 sin square phi. This 2 sin square phi will be out, and this will be out. So this is equal to 7 by 4. Already given 7 by 4. So, and we know cos square phi plus sin square phi is equal to 1. So we can write directly here. We can put cos square phi plus sin square phi, cos square phi plus sin square phi plus sin square phi. So first cos square phi plus sin square phi will be 1 plus sin square phi is equal to 7 by 4 is equal to sin square phi is equal to 7 by 4 minus 1. So this will give sin square phi is equal to 7 minus 4 by 4 is equal to 3 by 4. So sin phi is equal to plus minus root 3 by 4, root 3 by 2, sorry. This is going to be root 3 by 2, where it is. So phi is equal to sin phi plus minus root 3 phi 2, for which value of phi? So plus minus sine 60 degree pi by 3. So phi is equal to plus minus pi by 3. The value of phi will be plus minus pi by 3. And next is u v is 0. So phi is equal to, so the solution would be plus minus pi by 3. So we can find here where is plus phi is equal to plus pi by 3 plus pi by 3. Phi is no any minus pi by 3. So solution from this two part. So now let's move to the second term for theta. U v is equal to 0. So this is 1 sine theta, cos theta, I think. This is cos theta, no? Yeah, cos theta. This is cos theta. So just raise it. Cos theta plus 2 sine theta, scalar product of cos phi 1 plus sin phi 2 equal to 0. So again, cross product will be 0. So you can write 1 cos theta cos phi 1 plus 2 sin theta sin phi is equal to 2 is equal to 0. So we can take cos theta cos phi plus sin theta sin phi is equal to 0, as these are the normalized function, wave function. So now we can write this. This can be written as cos theta minus phi is equal to 0. So for what value of theta minus phi, this should be 0. So cos theta minus phi is plus minus pi cos 0 0 cos pi by 2 cos 0 cos 0 1 and cos pi by 2 is 0. So we can write here plus minus pi by 2. Okay, so cos theta cos plus minus pi by 2. So we can write theta minus phi is equal to plus minus pi by 2. So just take first term, theta minus so what we have phi is equal to plus pi by 3. So we can take phi theta pi by 3 is equal to plus pi by 2 and theta plus theta minus pi by 3 is equal to minus pi by 2. So here theta could be theta is equal to pi by 2 plus pi by 3. Theta is equal to minus pi by 2 plus pi by 3. So here 6 3 pi plus 2 pi, and this theta.
Now, question number 4 is this question we were asked in December 2016. So the question is, consider the operator pi, combination of P and A, where P is momentum operator and A is vector potential. So this is type of operator which is like a momentum of electron in an external magnetic field or external electromagnetic field. So now, and Q denotes the electric charge. Here Q is the electric charge. If B is equal to Bx, B as denote the magnetic field, the Z component of the vector pi cross pi. So we have to find the Z component of the vector operator pi cross pi. So how can we find? We can directly use pi x, pi y, pi z, pi x, pi y, pi z. So z component z will be for the k. So pi x, pi y minus pi y, pi x. So we have to find this term. So how can we write it as? Now the solution pi cross pi z component can be written as pi x, pi y minus pi y, pi x is equal to, we can write it in a commutation operator form, pi x, pi y. Okay. Now, what is pi x? Pi x is equal to px minus, from here, the x component of pi. So px minus qax, and pi y will be py minus qay. So we can write px minus qax, and this pi y will be py minus qay. Now solve it. Px, py plus px minus qay plus minus qax py plus minus qax minus qay. So px py, this commute, so this is 0, and here minus q px ay minus q ax py. If we take q square outside, minus q, this minus q and this minus q, q square will outside, and then ax and ay, so they will commute. So this term is also 0. We can take minus q outside. Px ay minus ay px plus ax py minus pyax. Now operate this on a wave function psi. What we will get, minus q, and now px is equal to minus I h cut del x ay minus ay minus I h cut del x plus ax minus I h cut del y minus minus I h cut del y ax to whole psi. Take minus I h cut outside. So here I q h cut. So we can write del x ay psi minus ay del x psi plus ax del y psi minus del y ax psi. Now I q h cut del x ay, this will give del x ay plus ay, yes psi, ay del x psi minus ay del x psi plus ax del y psi minus del y ax psi, this minus del ax del y psi. So this will be, this part will cancel out and this part will cancel out. So I q h cut, this is del x ay minus ax del y into psi. So this is z component of B. So what is B? Magnetic field B is equal to del cross A. So this is z component of magnetic field B. This is Bz. So we can write I q h cut Bz psi. So this is the solution. Let's look at the solution here. D. D is the solution. Now for this video we will stop here, and now we will try to solve another two questions in the next video, because the video is getting a little bit longer, more than half an hour or approximately half an hour. So Till now, thank you, and we will meet in next videos.